Hi everyone, my name is Vicente Arroyos from the University of Washington, and today I'm going to talk about our work on sustainable electronic designs and prototyping. This work is advised by Vikram Iyer from the University of Washington and Bichlien Nguyen from Microsoft. As technologies improve, devices like our smartphones keep becoming faster and more powerful, but that also means that old versions quickly become obsolete and turn into e-waste. Over 53 million metric tons of e-waste are generated annually, and this is increasing. This is a big problem because toxic material in e-waste can pollute the air, soil, and water. And some of the largest e-waste dumps are in developing countries, which raises environmental justice concerns. Our long-term vision is a circular production cycle for electronics. And to get started, we outlined 4 guiding principles we can take immediately to improve sustainability. First, we can decrease embedded carbon by minimizing the number of silicon chips using highly integrated systems on chips whenever possible. Second, we can improve circularity by using programmable components like microcontrollers that could be disassembled and reused in new designs. Third, we incorporate biodegradable materials whenever possible to build things like cases or circuit boards. And finally, we perform life cycle assessments to evaluate environmental impact and further optimize designs. We demonstrate this by building a working prototype of a computer mouse with these guidelines. On the left, you see a standard commercial mouse, and on the right, we have our mouse design, with the minimal components along with a biodegradable case and circuit board. We print our circuit using a conductive ink on a biodegradable board made of flax fibers, and 3D print a case using compostable materials like PLA or PVA. We can dispose of the circuit board and PVA case by dissolving them in water and recovering chips, which we successfully reuse. We perform a life cycle assessment of a conventional mouse design and compare it with our prototype. We find that our design reduces e-waste and carbon footprint significantly, and it enables reclamation and reuse of components to avoid further emissions and pollution. Our goal here is to show first steps we can take to immediately start making electronics more sustainable. And we hope that together with the research community, we can continue to innovate on novel design techniques, materials, and fabrication methods towards a more sustainable future for electronics. Thank you for watching, and check out our paper and video for more details.